The second use case we want to share is a little bit different. It is focusing on the process industry, and it has the focus from the manufacturer perspective of equipment. Of course, this equipment manufacturer, in this case, we talk about safety valves. Those safety valves prevent overpressure in the operational phase of in the process industry. For instance, in oil and gas, if such a overpressure occurs, they can vent, they can release the medium, and then it's important to know how much medium was released, because you need some approvals, and you need as well to fulfill greenhouse gas regulations to not remove, to release too much of this medium. So for the operator, it's important to know what is the medium released, the amount of medium released, and in addition, not only for documentation reasons due to regularity to fulfill regulatory boundary conditions, but as well to make its own operation efficient, because every product that he releases, he cannot sell, he cannot further process and sell. So the OEE is as well a result of knowing how much of medium released. And that's the chance of the equipment manufacturer of such safety valves to provide a digital twin for its safety valves, because he is able to give this information by a digital twin. Those safety valves, one kind of safety valve you see here with a pilot valve, and based on this pilot valve, we are able to take a pressure value of this pilot valve that opens and closes the main line. And based on this information, the OEM manufacturer can describe the behavior by a so-called behavior model or reduced order model, because he knows what is the internal structure of this component. So he doesn't need to make a reverse engineering by machine learning. He already knows what's inside and can use this information by a 3D simulation in the design phase, can derive a behavior model for the operational phase, where he feeds in a sensor value from the physical asset in the field to this digital twin of this valve, and gets an idea what is the amount of medium released. So he has a virtual sensor about the medium released, and that's very similar as well for a pump manufacturer. So we can, with virtual sensors, provide additional information about the product and the process that is in place. And that's the basis for the OEM to provide a digital twin to his customer as an additional service for the operational phase. So it needs a combination of both, of service providers and of manufacturers with this digital service, and the operator to get the whole thing running. But at the end, both sides benefit. The manufacturer benefits from the digital service he can provide as a digital additional revenue stream, and he gets a feedback as well about the real usage of the product and how to develop a further product generation, either a digital one, a digital service, or a physical one. And for the operator as well, operational efficiency is important, and to fulfill regulatory conditions. So for every manufacturer of products, there's always the question, what is the grade of digitization he wants to have for his own products? Instead of selling a physical product only, he could add additional digital service in terms of a digital model. For instance, for his customer or for a general contractor, a digital model to design the plant. Or for the operator, to be used as a digital twin in the operational phase, as we've seen it in those two use cases. But on the other hand, he can do a step further and can provide his own digital service based on those digital twins. For instance, for predictive maintenance, in terms of getting the maintenance business back to his house, getting an idea what is the right time to offer specific parts and capacities of manpower he can provide for his customers. He can provide services in terms of recommendation of usage. That was we have seen for the Verbund use case is very similar as well as a service to be provided by the manufacturer of its own component to get a better operation of the whole plant, for instance, as well for the valves, to reduce the number of venting events. In addition, we see as well the demand of such profile-based applications for early phases in the sales process. For instance, if customers are able to provide a usage profile, such digital twins can take sensor data as a usage profile to help in the selection of the right product configuration. Yeah, that are use cases that are helpful for the OEM, but of course it needs a combination in the collaboration of OEM and operator.